This is Algebra 1, 7.7. We're going to talk about geometric sequences today. But before we do that, we're going to talk about kind of the background information. First thing I want to know is, what is a sequence? What's a sequence, guys?
An order something's in.
An order that something's in. It's an order. It's a pattern. It can increase, it can decrease, it can do a couple different things, right? So 1, 2, 3, 4, 5 is a sequence. 5, 10, 15, 20 is another sequence. Okay, so everybody's okay with that. Now, that's a sequence. Do you guys remember back in 3.5, we did arithmetic sequences. We did arithmetic sequences, guys. And arithmetic sequences did something like this. 1, 3, 5, 7, ... They went up by 2. They went up by 5. They went down by 3. They had a common difference. We call that common difference, guys, D. A common difference. And the key here was you add or subtract to get, add or subtract D to get next term. You guys remember that? And then one of the things here, going back to this idea of 1, 3, 5, 7, ... How do we know this was an arithmetic sequence? Okay, we look for, is it going up or down by the same constant, right? And then you say, yeah, it is. But what if I didn't see that the numbers were? How was that work? What was that work that we showed to find that common difference? We subtracted them, yes. How did we subtract them? We did this. You guys remember this now? We did 3 minus 1, 5 minus 3, 7 minus 5. And we came up with the idea that, hey, all of those equaled 2. They have a common difference, or D would equal 2. You guys remember that? Now, here's the thing. If I wanted to know all the way to the 10th term, you would just got to keep on adding until you get to that point, right? But back in 3.5, we actually came up with an equation that would allow us to find for any term at will. So if I want to know the 100th term, I could plug in 100, got a term. If I want to find the 10th term, I just plug in 10, I have it. And the answer to this, or the nth term, a sub n, was the first term plus, who remembers? Some people in the last hour remembered this.
N minus 1.
N minus 1 times?
D.
Teachers and students, excuse the interruption here.
So, this equation, a sub n equals a sub 1 plus n minus 1 times d. The reason we learned this back in section 3.5 was the fact that when you put in values for a sub 1 and for d and cleaned it up, it turned into slope-intercept form. You guys remember kind of that? It ended up looking like something like 4n minus 8, which is slope-intercept form. mx plus b. So we kind of introduced this idea because it's a constant change. Constant changes are linear. Okay? So the key is, once you know A1 and you know D, you have an equation. So for our problem, I know A sub 1. What's A sub 1? What's the first term? 1 plus. We don't know N. I'm going to leave that. And what was D? 2. And so if I distribute, I get 1 plus 2n minus 2, or 2n minus 1 is, I'm going to take this out of here, A sub n. So if I want to know the 10th term, I put in 10. 2 times 10 minus 1, which is what? 19. So if you were to continue that sequence that we started there, 1, 3, 5, 7, 10 to the 10th term, you would end up with 19. Ring a bell? Okay. Now, let's get into what we had to do today. Today, we're going to talk about a geometric sequence. A geometric sequence, so now, geometric sequence, great handwriting here. Geometric sequences use multiplication. Use multiplication to get to the next step. Which means they have not a common difference, they have a common ratio. And that common ratio we call R. So, if I had something like 1, 2, 4, 8, 16, can you tell me the next 3 terms? So what are those next 3 terms there? It's 32
64
and 128. Because it's just doing what to the number before? Multiply by 2. So, like before, we were able to look at the problem and do a little bit of subtracting to find the common difference. I think everybody would realize that 2 minus 1 is 1, but 4 minus 2 is 2. That's not the same. Wait a minute. It shouldn't be the same because this one is a geometric sequence. The last one was a arithmetic sequence. So therefore, we're going to do the same little caret thing going on here. Whoops. Where am I at? I lost track. Here, 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 here. Okay? But when I go to do this, I'm not going to subtract. I'm going to divide. Do these all have the same ratio? 2, 2, 2, 2. So that means R is equal to 2. Therefore, this is a geometric sequence. Any questions? Given this sequence, tell me the next 3 terms.
Can I use my calculator?
Yes, you may. So, to get this answer, we need to establish what we have. So, are we saying this? Are we going to divide these or subtract them?
Divide.
Okay. So 15 over negative 3, negative 75 over 15, 375, that looks like 325, 375 over negative 75. When I divide all of those, every single one of them gives me. So we know that the common ratio is negative 5, which means to go from 375 to the next term, I
Multiply it by
negative 5, which is
negative 1875.
and then it becomes positive
9375.
And then it becomes negative 875. Numbers can't get in there. Here we go. No. Guys, that's not so bad, is it?
Nah.
No. Then here's the thing. Now they're going to trick you. They're going to trick you because they're going to do something like this. And it's going to say, given this sequence, you need to tell me, is this an arithmetic sequence, is this a geometric sequence, or is it neither? And then, if it is geometric or arithmetic, find the next three terms.
Wait, that's...
So if it's arithmetic, then you just take the common difference and keep adding or subtracting. If it's geometric, you keep multiplying. Yeah? So, we're good. We like it. So, we don't know, right? At this point, you're looking at this and saying, I don't know what kind that is. So, guess what? I'm going to start with arithmetic sequence. I like subtracting. So, is 8 minus 2 the same thing as 14 minus 8?
Yes.
Which is 22 minus 14.
Yes.
So this is 6, 6, 8.
Oh,
Oh my goodness.
that's a shame.
Therefore, they don't work out. Not arithmetic, right? Test it over here then. 2, 8, 14, 22. 8 divided by 2? 14 divided by 8.
I don't know.
That's a 4, and 14 divided by 8 is definitely not 4. It's not even 2. It's 1 point something. So therefore, it's not geometric either. That means it's
Neither.
neither. Whoops.
Who says
Neither. Now, last time when we first started talking about the arithmetic sequences, there was a way to figure out the 10th term, the 100th term, 1000th term if you want. So there's got to be a way that if I give you that sequence, that you guys should be able to do the same thing for some term out in the future. Would all of us agree that if I did this magic here, it'd be 36 over 24, 54 over 36, and 81 over 54, which is 1.5. So every single one of these is 1.5. That means we have a common ratio of 1.5. So if the common ratio is 1.5, if I start at 24 and I multiply it by 1.5, I get 36. If I multiply 36 by 1.5, I get 54, and then again and again and again. Let's think of the 10th term, because it's relatively close, right? The 10th term is right there. So how would I get the 10th term? Wait a minute, wait. Let's think of this. I start at 24 and I multiply by 1.5. And then I multiply by 1.5. And then I multiply by
1.5?
and then I multiply by
1.5?
and then I multiply by and one again and again and again. Wait a minute. 1.5 times 1.5 times 1.5 times 1.5 over and over and over is just doing what to 1.5? Squaring it, cubing it to the 10th. It's taking it to an exponent. So wait a minute, guys. Would it make sense that if I took 1.5 to some power, I could eliminate that whole entire work of having to keep multiplying by 1.5?
Yeah.
okay. So you guys are like, oh, maybe it's the 10th one, right? 1.5 to the 10th power. What is 1.5 to the 10th power?
Let's find out.
57.66? Interesting.
That's not right.
Can it be right?
Yes.
Well, let's see. 1, 2, 3, 4. What would be next? 5, 6, 7, 8, 9, 10. That's 10 way over here. So 10's over there. I'll erase this one. What's next? 81 times 1.5.
121.
Oops. Oh, hold on. 121.5. Okay, next.
182.25.
0.25. Next.
273.375.
Next.
410. .1625.
Next.
615.9375.
And 10.
922.64.0625.
That's 922 something. You guys are trying to tell me that it should only be 53 something. What do you mean multiplying by different numbers?
Multiplying 1.5 by 1.5 and multiplying 36 by 1.5.
Oh, wait a minute. What's the first term, guys?
24.
So you're if the equation was just 1.5 to the n, couldn't I just put 1.5 to the first power and I'll get 24, right? No. So how am I going to take into account something here? Wait a minute. I think we are forgetting something about that constant or some number. We didn't start enacting 1.5 until after term 1. When did we first start to multiply 1.5? Going from 24 to 36. So 24 was already there, right? That's our first term. Oh, so shouldn't we put 24 in front of this? 24 times a whole bunch of 1.5s will give me my answer. Well, then if I want my 10th term, I just put 10 in for n. Does that work? Do I get 922 some?
No.
Is it bigger or smaller?
Bigger.
Oh, it's bigger.
Like 400.
By about 400. Wait a minute. 900, 400, that's about half, isn't it? Rich? So, if 10th power was too big, let's try 9 ones. What is 1.5 to the 9th power times 24?
922.
It's the answer.
What?
So you're only multiplying by 1.59 times.
Oh, there we go. We got it.
Oh!
Because
Explains me.
we're starting with a number term already.
Okay.
We're not starting with the multiplication of 1.5s until term 2. It's the term and the number of times 1.5 is used is always 1 less. So the answer needs to be not n, but n minus 1. Let's test it out, guys. Let's do the 5th term. The 5th term should be the 1, 2, 3, 4, the 121.5.
Oh my gosh. Would you look at
Does it work?
Yeah.
So, we just kind of built the rule for this particular problem. Can we back out those pieces and form a very general equation for a geometric sequence?
No.
Yes. I think I have.
Now, I'm going to go back to the slide with geometric sequences so we can put it there. Here's our sequence page. I want an equation. What's the equation? Monica.
n
AN, yep,
equals
equals.
A. I'm thinking about A, parentheses R, close parentheses, the exponent, N minus 1.
Super close.
Where is the A1?
It's A1.
Oh.
A1 as in the first term times the common ratio N minus 1 times.
I won't shake, so. That's not what.
Boom, guys. Guys. Here's a really cool thing. It doesn't matter if it's an arithmetic sequence or if it's a geometric sequence. If you know A1 and R, you got a geometric sequence. If you know A1 and D, you have an arithmetic sequence. Boom. You can find the equation. You can find any term you guys want. So, in your homework, they're just going to give you a sequence and then have you determine if it's geometric, arithmetic, or neither. And if it's one of those things, it may ask you to write the equation, like we just did. So, let's do a quick example of one that you guys should have to find. -6, 12, -24, 48. And again, once you have an equation, you can find any term you want just by plugging in a value for n. Okay, guys, write the equation. Guys, is this a geometric or arithmetic sequence? So let's test her out. 12 divided by -6. 24 negative divided by 12. 48 over -24. I get -2, -2, -2, which is an R value because it's a ratio. Yes, that's awesome. It's geometric. And now to write the equation, it's as simple as saying A sub n equals A1 times R to the n minus 1, which means A sub n equals, always write down the blank first before you fill it in. What's A1? -6 times to the done. Now wait, guys. Why does this work? Why is it that these equations, when I put 0 or 1 in, I end up with -6? Or the last problem, which might have been arithmetic, why does it still seem to work? Let's go back to the equations. Look at this equation. What happens when I put in 1? You get 1 minus 1. Which is 0. R, anything to the 0 power is 1. And 1 times A sub 1 is A sub 1. It gives you the first term. That's why when you put in 1, you get A sub 1. Backing up even further, look at this problem. What happens when I put in 1? 1 minus 1.
0.
And 0 times anything is 0. And if I add 0 to A sub 1, I get
0.
A sub 1. I get the first term. It works in both cases. Your homework, guys, which should go pretty quick, page 441, 1 through 13. Have a great day.